Hey guys, it's Mr. Riz, and we're going to continue chapter 1, and we're going to focus on the very last section, a short section, which is 1.5, about infinite limits. Pretty easy. Alright, so we're going to be able to determine the infinite limits from the left and from the right, and find and sketch any vertical asymptotes of a graph of a function. Alright, so infinite limits, what they are. Consider the function f of x equals 3 over x minus 2. It's right there. So if we look at this figure here, we can see that there's an infinite limit because as x approaches 2, which is a discontinuous point, we can see because that would make the denominator 0. As we approach it from the right, it goes towards infinity, or goes all the way up and up and up. As it goes from the left, it goes down and down and down and down towards negative infinity. We can verify this by plugging it into a calculator and creating a chart. Now this is probably the best way to determine the approach from the left and from the right for right now. Later on in the year we'll determine another way to determine it without using a graphing calculator. But for right now, the best way to determine the left and right bound approaches is to use a graphing calculator. So what we can see is that the limit as x approaches 2 from the left side, and remember we put the little negative sign there on the left side, we're going towards negative infinity. And as we go from the right side, we're going to regular infinity or positive infinity. Now keep in mind the symbols infinity and negative infinity refer to positive and negative infinity respectively. These symbols don't represent real numbers. They're just convenient symbols used to describe unbounded conditions more concisely. So they are not numbers. So when the limit goes towards infinity, it still does not exist because it's not a real number. But we can be a little bit more accurate with our description. All right. A limit in which f of x is increasing or decreasing without bound as it approaches x is called an infinite limit. Now what we could have, if f of x approaches c the same way from the left and from the right, if it's going out of bounds completely, we can describe the whole location as f of x approaches c equals infinity, or equals negative infinity, as long as it's going in the same direction both ways. We can see that in the function f equals 1 over x minus 1 squared. We can say the limit as x approaches 1 equals infinity. We cannot say the same thing for the other function, f of x equals negative 1 over x minus 1, because this is not, this on the left side is going towards infinity, but on the right side is going towards negative infinity, and they are not equal. In fact, if you want to get crazy, technically infinity is not equal to infinity, but at least here it's going towards the same unbounded behavior. And that's basically what we just said. Alright, so now we have the function. Say we have 3x plus 12 over x squared minus x minus 20. I want you to find the vertical asymptotes. In fact, I would want you to be able to, by the chapter 1 test, describe all discontinuous points. Well, if we look at this function, we can rewrite it as 3x plus 12 over the bottom factors out to x plus 4 times x minus 5. So we know that it's discontinuous at x equals negative 4 and x equals a regular 5. Well, now we need to determine what type of discontinuity. Well, how we can do that is let's factor out the top. In the top we could factor out a 3, so we get 3x plus 4 over x plus 4 over x minus 5. Now we learned from the last section these would cancel each other out, and so this is a removable discontinuity, and so on a graph we would have a hole. The equation would simplify to just x minus 5. We could figure out that hole is located at the point 4 or negative 4, and we're going to plug in negative 4 in for here, and we get 3 over negative 9 for negative 1/3, there is a hole in the graph. Now if we look, 5 doesn't remove at all. So 5 is non-removable. And so we know that there's going to be a vertical asymptote at x equals 5. Now, for right now, we cannot tell if this graph is going to go, the vertical asymptote going to go up towards infinity, if it's going to go down towards infinity from the left. We don't know if it's going to go up or right. We don't know if they're going to meet together in the middle or not. We just know there's going to be a vertical asymptote. Later on in the year, we'll figure out how that goes. But we can always double check with if we got this right with a graphing calculator. So we'll take a look at the graph. And we can see right there, there is a vertical asymptote right at 5. And there should be a hole at negative 4, but the calculator's no fun. Even if we zoom up all the way, we still won't be able to see that tiny, tiny hole in the graph. Alright, pretty easy section. This concludes Chapter 1, so after this we will have a Chapter 1 test. If you have any questions, rewatch the videos, and good luck.